Hello, welcome you to this session on solutions to assignment. We will solve the assignment questions and find out why the answer should be as shown here. Let's see the first question. The first question is a reaction where zinc reacts with copper sulfate to form zinc sulfate and copper. This question has three sub-questions. The first one is to find out if it is a redox reaction. If it is a redox reaction, which substance is getting oxidized and which one is getting reduced, and then representing the reaction in half reaction and then balancing the reaction. Let's start solving this. This is a redox reaction. Just by looking at the reaction, we can say it is a redox reaction. However, if we want to define it based on the definitions that we have learned, we see that zinc here is gaining oxygen. So zinc and copper is losing electron by giving out its sulfate ions. Now, since there is movement of oxygen itself, we can say that this is a redox reaction. If you want to define it by another method, we can also say that zinc, which had an oxidation state of 0, increases here to +2, and therefore this is a redox reaction. Now, answer to the second part of the question, which species is getting oxidized and which species is getting reduced, we can easily say here that zinc is getting oxidized. Zinc is getting oxidized and copper is getting reduced. That is because we see that zinc is gaining oxygen, whereas copper sulfate here loses the sulfate ion to become copper, and hence it is getting reduced. Answering the third part of the question, represent the reaction in half reaction and balance the reaction, we see that we have to separate the oxidation reaction and the reduction reaction here. So we see that zinc becomes Zn2 plus by giving out 2 electrons, and then we have copper taking 2 electrons to give us copper. However, we should know that this is happening in the aqueous conditions, because of which we have copper sulfate breaking down to copper sulfate to copper and sulfate ions, and zinc that is formed would react with the sulfate ions to form zinc sulfate. So we have these 2 electrons that would get cancelled, and the final reaction would be zinc, which is in the solid state, plus copper sulfate, which is in the aqueous condition, would give rise to zinc sulfate plus copper. One thing, this would be a oxidation reaction and this would be a reduction reaction. Note that whenever there is decomposition reaction happening, that would be an example for redox reaction. In this particular reaction, there is no need to balance because this reaction is self-balanced. Zinc gives out 2 electrons and copper ion accepts these 2 electrons, so it is self-balanced reaction. Moving to the second question, we have magnesium reacting with carbon dioxide to form magnesium oxide and carbon. We need to write a balanced equation to represent this above equation and identify the substance that is oxidized and reduced. So here we have magnesium reacting with carbon dioxide to form magnesium oxide and carbon. So if I need to balance this, we have magnesium 1 mg 1 mg here, but we have 2 oxygen atoms, so I need to make this 2 MgO, and then hence I will write it as 2 magnesium, and carbon is balanced. So this is the balanced chemical equation for the reaction. Now we need to identify the substance that is getting oxidized and the one which is getting reduced. We see that magnesium here is gaining an oxygen to form magnesium oxide. So this would be an example for oxidation reaction. And carbon dioxide is losing its oxygen to magnesium to form carbon, and hence this is a reduction reaction. So we can say that in this particular equation, magnesium is getting oxidized and carbon is getting reduced. The next question is where we are talking about two halogens, the chlorine and iodine, and their reactions with hot iron, and also we discuss about their oxidizing power. There are two reactions that are given where they react differently with an aqueous solution containing thiosulfate ions. We need to find out the oxidation number of sulfur in three different ions: S2O3 2-, SO4 2-, S4O6 2-. We need to discuss about the relative oxidizing power of chlorine and iodine, and then we need to find out if our answer is right by taking one of the reaction of halogens with hot iron. Try to find out if our statement made in the second question is true or false. Let's answer the first part of it, which is finding out the oxidation number of sulfur in three different ions. We will take the first one, which is S2O3 2-. Let's consider the sulfur's oxidation state as X. So we will keep it as X plus of -6, -6 coming from oxygen, 3 into -2, which is -6, has a charge of -2, so this becomes -2. So we have S2 oxidation state, which is +4. So sulfur here will have an oxidation state of +2. In the second example, where we have SO4 2-, let's again have the sulfur's oxidation state to be plus, and -8. -8 is 4 times -2, which is -8, giving rise to a charge of -2, so we write it as -2. So here X is equal to +6. So sulfur has an oxidation state of +6 in SO4 2-. The third one is S4O6 2-. Again here let's have X for the oxidation state of sulfur, and then we have oxygen having -2 times 6, which is -12, giving rise to a charge of -2. So here we have X is equal to -10, but X here is S4, so we have S as 2.5. So here we see that sulfur has an oxidation state of 2.5. So in each of these ions, S2O3 2- has an oxidation state of +2, SO4 2- has an oxidation state of +6, and then S4O6 2- will have an oxidation state of 2.5. Now with this, we need to find out the oxidizing power of chlorine and iodine. Now when we compare the oxidizing ability of chlorine and iodine, we see that chlorine has more oxidizing ability than iodine. That is because of few factors. We see that a good oxidizing agent is the one which has large affinity for electrons. It should have high electronegativity, then it should have an increased oxidation state, which is imperative from the previous question that we have answered. Chlorine has a higher oxidation state because when the oxidation state increases, it becomes more electronegative as well. So we can say that this has the ability to take electrons from iodine ions as well. But when we say chlorine has more oxidizing ability, It's only when compared to iodine. Fluorine has a much better oxidizing ability amongst halogens. Looking at the equation where it reacts with iron, we see that there is two reactions here. We have 2Fe plus 3Cl2 giving rise to 2FeCl3, and then we have one more reaction where Fe plus I2 gives rise to FeI2, right? Now here we see that iron had oxidation state of 0 and here it is plus 3, and in this second equation where it reacts with iodine it was 0 where it changes to plus 2. Now you see in the first reaction that iron is oxidized more from chlorine because the number is plus 3 than iodine. That is the reason why we can say that chlorine has a more oxidizing ability when compared to iodine. Moving further, we have one more equation to balance, which is the balancing the ions. We have iron ion and ClO3 minus ion in acidic medium, so we have H plus as well, giving rise to Fe3 plus ion, Cl minus ion, and water. So let us see what would be the answer for this reaction, for this question. So the first step in balancing is to identify the substances or the species whose oxidation states have changed. So we see that Fe here changes from plus 2 to plus 3. And then we also have chlorine whose oxidation states changes from plus 5 from ClO3 minus here to minus 1. Now this is a 1 electron change, and plus 5 to minus 1 would be 6 electron change. Therefore we can very easily say now that the ratio of iron to ClO3 minus, we can say plus 2 as well here, is 6:1. So we can start putting it here by writing 6 iron ions and 1 ClO3 minus, giving rise to 6 Fe3 plus and 1 Cl minus. The second step would be to balance hydrogen and oxygen atoms. So we have 3 oxygen atoms here in the reactants, and we have only 1 as of now product. So what we need to do is we will write 3 water molecules, and once I write 3 water molecules, so the next thing that I need to balance is the hydrogen ions, which is 6H plus. In a reaction like this, H plus indicates that the reaction is happening in an acidic medium. Now the reaction appears to be balanced. However, we need to check the charges on LHS and RHS. So on LHS, we have 6 into plus 2 plus chlorate ion having minus 1 charge, and 6 from hydrogen ions, which comes up to 17. And on RHS, we have 6 into minus 3 plus of minus 1. Water has 0. So even here we see that the charge is 17. So this reaction is balanced. The last question in the assignment is to write the full ionic equation including the state symbols. Writing the state symbols is important because that tells us the nature of the environment where the redox reaction is happening. So let's write for the first one, Cr2O7 2 minus in aqueous conditions plus 14H plus in its liquid state plus 6 electrons gives rise to 6 Cr3 plus in aqueous condition plus 7H2O. The second equation would be Fe2 plus in aqueous condition giving rise to Fe3 plus plus 1 electron. Now if we just notice here, there is 1 electron on the product side, whereas 6 electrons are required for the first reaction to take place. Hence we need to multiply this by 6 times. Now when we do so, we will have reactions as 6Fe2 plus, giving rise to 6Fe3 plus and 6 electrons. So let us write the full ionic equation. We see that the electrons on the LHS and the RHS would get cancelled. So the final equation would be Cr2O7 2 minus in aqueous condition plus 14H plus in liquid state plus 6Fe2 plus in aqueous conditions would give rise to 2Cr3 plus 7H2O plus 6Fe3 plus. So Fe3 plus in aqueous condition and 2E chromium ions in aqueous conditions. So this would be a full ionic equation including its state symbols. The second one is where we have zinc in its solid state giving rise to Zn2 plus in the aqueous condition and 2 electrons. And the second equation is where we have Fe3 plus taking up 1 electron to give us Fe2 plus. Looking at both the reactions and trying to balance the electrons from these two equations, we need to multiply the second equation with 2. So this becomes 2Fe3 plus 2 electrons giving rise to 2Fe2 plus. So let's try to write the full ionic equation. We have zinc in its solid state plus 2Fe3 plus, which is also in the aqueous state as given in the problem, with 2 electrons would give rise to Zn2 plus in aqueous condition and 2Fe2 plus, this again in the aqueous condition. So here we see that the electron on the LHS and the RHS get cancelled, and finally this would be the full ionic equation with their state symbols. So this is a video clip on the solutions to the assignment. I hope this was useful. A ready reckoner is given as an attachment. Download this to have a quick review and revision of the concepts that's learnt on this topic. Thank you.